Okay, this video we're looking at Unit 3A, which is uses and abuses of percents, but our main focus is going to be the uses of percents. That's where we're going to focus our energy, but these things can definitely be abused, and they can be used to be a little bit confusing. Such as this example right here. News reports frequently express quantitative information with percentages. Unfortunately, while percentages themselves are rather basic, they are just an alternative form of fractions. So when we're talking about fractions, we're talking about, or percents, we're really just talking about fractions. Percent means per 100. Okay, they can often be used in very subtle ways, and you have to, I guess I should say, as you gain a better understanding of percents, you can kind of start to see through how these are being used to decipher whether or not it's good information or not. This one right here says the rate of e-cigarette usage among middle school students was up 36% to 5.3%. That statement right there, all the percentages are used correctly, but when you say up 36% to 5.3%, it's not totally easy to understand those kind of things. So, today, again, we're going to focus on the uses of percentages and why they are very important, but just know that these things can be abused, or they can be stated in ways that are true but hard to interpret. So again, the first thing we're going to do is a brief review of percents. Okay, a percent, another way to say it is, or think of it, is per 100. And so we're going to, in these three examples I have right here, we're just going to express each of the following in three different forms: a reduced fraction, a decimal, and a percentage. So when you see 44%, okay, as a decimal for percent, you're just going to move that decimal place left 2 when you go from a percent to a decimal. So 0.44 is 44%. Or 44% as a fraction is 44 over 100. Again, percent means per 100. So we take 44 and we divide it by 100. And if you reduce this fraction down, 4 goes into 44 11 times and into 125 times. So here are the 4 different ways to represent 44% as a percent, a decimal, and a reduced fraction. But just remembering that it's that fractions are per 100 is really helpful, and moving the decimal place a couple places to the left or right, depending on what you're given, will help you make those adjustments. So for example, on 18 we have 0.85, so that's given in decimal form. So that's going to be 85%, because when you're in a decimal form you just move it 2 places to the right. Or, because if you think about it, 0.85 is 85 hundredths, and 85% is 85 over 100. So they're synonymous there. So 85 out of 100. And if you reduce this thing down, 5 goes into 85 17 times and into 120 times. So you'd have your 3 representations would be those 3 right there. Okay, last, if we start with a fraction, 4/3. Okay, hopefully you can see 4/3 is bigger than 1. So this is more than 100%. So 4/3 is the decimal 1.333, and that just keeps on going. So as a percent, again, you move that decimal place 2 places to the right. So this is 133.3%. So when you see a fraction that's greater than 1, then you're going to have a percentage that is greater than 100%, because 1 is 100%. So if it's greater than 1, you're going to have number greater than 100%. So there's your 3 representations. Again, that's just a brief review of percents, how you switch from decimals to percents to fractions, and whichever direction you need to go. But the idea of being able to convert is very crucial. When we do calculations, we are going to be using either the fraction or the decimal. So we're going to be using, so in this example right here, you would either use the fraction or the decimal. So just remember that. In calculations, almost always are we going to change those around. Okay, now this next one, where we're a good application of percentages is when we're looking at ratios, because again, ratios are fractions, percents can be written as fractions, and so forth. So we want to compare the following pairs of numbers, A and B, in 3 ways. So we want the ratio of A to B, then the ratio of B to A, and then complete the sentence, A is blank percent of B. Okay, and that third part C, A is blank percent of B, will be extremely is an extremely applicable idea. So let's look at this. So in here we have that A is 40,229,000 is the number of Americans over age 65 in 2010. B is 88,458,000 is the projected number of Americans over age 65 in 2050. So we want to figure out the ratio from A to B. So from A to B, that ratio is going to be 40,229,000 over 88,458,000. Okay, that's the ratio from A to B. So that's A divided by B. So this ratio we get right here turns out to be about 0.455. So the ratio from A to B, it's on a 0.455, or we'll see later here, it's A is about 45% of B. Let's see, part B, we want to go from ratio from B to A. So if we go from B to A, then we're going to take B, which is the 88,458,000, divided by A, which is 40,229. Excuse me, 40,229,000. Well, just totally airballed on that. Okay, if you do this out, this is approximately, I'm rounding these to a couple decimal places here. This is approximately 2.20. So in part C, what we would say when it refers back to A is to find out what percent of A is to B, we just look at the ratio. So we found that the ratio was 0.455. So we just need to say 0.455 is the same as 45.5%. Oops. Of B. Okay, so we got to change those decimals into percents in order to represent them as as percents. So in this case, A is 45.5% of B, or in other words, you can think of it as a little bit less than half of B. And you could switch it around. You'd say B is, and you'd switch 2.2 to a 2%. B is 220% of A. Okay, so these last couple examples for this video. We want to express the first number as a percentage of the second number. Okay, so we've got Apple's 2015 revenue was $233 million compared to Walmart's $482 million. Here's one way that I like to think of this. I like to kind of think of this in English first as to how I would write this out. So we have 233 million, so I'm just going to write that as, since they're both in million, I'm just going to use the 3-digit number there. So I'd say for Apple, 233, if I'm comparing it to Walmart, I'd say 233 is blank, or what percent of 482. That's how I would think of it in English terms. If I wanted to compare 233 million to 482 million. Now if I change this over to a kind of a math term or math equation, when I say 233, when you see the word is, that's usually looking or representing equality, is blank percent. So that's an unknown. So I'm going to say that's X percent of 482. So then, now I have an equation 233 equals X times, so when you see of, I should have said that, when you see of, that's a product or multiplication. So you get 233 equals X times 482. So now you can just quickly go ahead and solve here. So divide by 482. And you get 233 over 482 equals X. And if I take the 233 and divide it by 482, I get about 0.483. And as a percent, that's 48.3%. Okay, so when I think of this, I say 233 is 48.3% of 482. So that just gives you an idea in the percentage of one number to the next. Okay, so the next one we look at, the full time year-round median salary for U.S. men in 2015 was $50,383, and the full-time year-round salary for U.S. women in 2015 was $39,621. So again, we're saying $50,383 is what, or blank percent of $39,621. So again, if we write this out as an equation, 50,383 is, which is equal to blank, so an unknown X, times, so that's a times symbol there, 39,621. So I'm going to divide by 39,621. So I get X equals 50,383 divided by 39,621. So that comes out to approximately 1.272, or as a percentage, 127.2%. Okay, which hopefully makes sense because 50,000 is bigger than 39,000, so you would anticipate that it's going to be a little bit bigger than 100%. So that's our first look at percentages and doing some basic conversions and calculation percentages. Will continue in part 2.